Hello again. This time I would like to show you how to do a design of a small project where we drive a 7-segment display using FPGA and VHDL language. To start with, we're going to show some of the hardware because this is essential. So what we've got here is a 7-segment display representation. This is what we've got inside a 7 plus 1 diode, each one corresponding to segments. So segment A diode is this one, B, C, D, and just clockwise, and G as the last one, and DP for a decimal point, representing a dot or comma. This part, the top one, is just the part of the board, a common anode 7-segment display, because this one is used in Nexus digital system builder board, and this is what we're going to use. So there is no point of showing the other one. This information is easily available on the internet everywhere. If you type a 7-segment display in any of the search, then you'll be pointed into many of those. Let's bring the idea of how to drive it, because it's a little bit unusual recognizing this as a PNP. How to drive it? We need to enable the anode here by polarizing the PNP transistor, which is different than the NPN transistor saying. So what we need to do is to bring the anode drive to low or to ground, but generally we want it to have it in low state. In this case, the current is allowed to go through the transistor down to the anode of the display, and then to show up or to light up any of these diodes, we need to bring a corresponding pin. Again, the same story. We want to have a high potential, 3.3 volts, and then again we bring in this one to the low state, or connecting to the ground, but low is enough. So 0, otherwise saying low, I mean 0. This is corresponding part of the schematic of the digital system builder Nexus board. You can find any of those in the reference manual. I'm having this one, so this is what I'm showing. But if there is any like this built-in in your board you're using, because this tutorial is universal for each of the FPGAs, you can easily using this code with the small tweaks maybe to program any other FPGA. So here we want to use only one of the digits. I'll show you later, or maybe in next video, how to use all 4. But in this case, we using F12 to drive anode 3, and then this one becomes activated. Later on, we show, or we light up any of the required segments by bringing any of those pins to low state. So let's say if you want to display number 2, we will bring segment AB, that C will be inactive or 1. It's like what I'm saying here, when we bring 0 to activate something, we're talking about negative logic. That may be helpful in future in any other projects, or in electronics generally you can hear negative logic. So 2 will be corresponding to the segments A, B, D, E, and G. The rest stays ones, so it's inactive. What else we would need is the 4 switches, because we can hard code the number to be displayed on the display, but it would be more interesting if we have a chance to do interaction with our board. So let's use SW0 to SW3 to easily switch between 0 and 1s. And in this case, we can select, it's called a BCD, binary decimal code. So if we set, let's say 0, 0, 0, 0, the display will show 0. And then if we go for, let's say 1, 0, 0, 0, then 1 is in the position of 8, so 8, or 1 1 1 1, which we do letter F, which is 15 in our representation. Let's start the project. We name it 7 segment display, and then our device is the same for Nexus Digital Builder, and the enclosure or package FT256. Now we can finish that part, and then we are adding a new source, which is VHDL module. We call it 7 segment. And next, now we need to decide of the ports. So we need anode. It's only one anode, so in this case we do that, defining as out. We need segments. This is again output, and it's a bus of width 7, so we do 6 to 0, which is 6. If you will count on your fingers, you'll see that we include 0 as a valid segment, and we need switch 0 to 3, which is going to be deciding our digit to display, and this one is also a bus of width 4. And then we can finish that part. It's our little frame here, and now we're going to fill it up with our desired work. Also, before that, we add constraint file which will do a connection between higher level and pins. When we are here, we can easily add the segments. This is exactly those segments, F13 for sector or segment A, B, C, D. You can copy from here, just keeping the proper arrangement and syntax. What we would need also is the anode and buttons or switches. So we've got anode and then 0 to 3 pins. Save it, and then we're going back to our file here. This one is quite simple. We just need a sensitivity list, which is switches, and a change in switches should trigger changes in the behavior or in the reaction of the module. So that, let's bring it now. To save on time, we just paste it. What we do here, this is our process, and it's dependent on the sensitivity list of the switches. Any changes in switches makes this thing to be processed or to be executed. And what we've got here is the reaction to the switches. The case decision thing is done here, and this is our place where we looking at. So anytime when the switches are set in 0 0 0 0 position, low 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 low, the segments are going to be executed in this way. But be careful here, because this thing is done in such a way that those are done in the opposite way, opposite by saying this is G, F, E, D, C, B, A, this way. So the segments from A to F are lit and segment G is extinguished. So you can see here we want around for 0, and G we want to be invisible or dim. And this one is done in this part. So every digit and later on letters are defined in such a way, because of course, as I explained that earlier, we want to have the path to be closed. We've got it activated, so the current can flow. You just need to provide a low state to any of these outputs here or cathodes, and then the current starts to flow, lighting up particular diodes. Okay, we don't need that, or rather that will be display. We can comment it for later if you want it. So saving, and let's synthesize and build the project. Errors. Let's see, what is it complain on? I pasted in the wrong place. So as the programmer's part of life is to debugging, so trying to read wherever we want, whenever we will meet any problems, read the error description. If you don't know what to do with it, paste it in somewhere like a Stack Overflow, Google, and then search for solution. There will be plenty of recommendations, I can bet. And the last bit is programming file. There is something maybe it's good to tell now. It's the what do we do with unused pins in the project. So there is an option to set it up. Anyway, let's try. Our file. The first thing is this cclk. So this thing is to set up the prom to be done every time we power up the board. So we do change the settings to have it properly done for our case. So we need a JTAG. Going for startup options, I said it quite of times in the other videos, and then we do it again. So what I'm expecting now, because the default settings for the unused files is pull down, we can expect that all of our displays will show up. I wouldn't be surprised if it happens. Yes. Okay, I don't see the board. Okay, we've got it sorted. Yeah, so all four, they will be displaying all the same because the segments are connected to one, and we display all four segments. Why is that? Well, it's quite simple. Those transistors required tiny current to be activated, and if we have pull down of all these unused pins, then it could happen that all of them be active. So we either disable those by pulling them up, but that requires changes in our code. We can also decide to go into settings. When we do have this generate programming file, properties, and we've configured it, that's here, unused pins, unused IOB pins, we've got pull down. When we do it pull up, we will need to redo the generating programming file, but then only wanted will be working. And here we go. That's only one, because not the unused file, unused pins are being pulled up, so there is no way the others anodes transistors can be. But instead of that, we've got all these tiny LEDs being on, because if you look at the schematic, here we go, they are pulled up. So now the current can flow down. I don't see the whole thing, yeah, here. So because they are up, unused unused pins, these ones, they are high. So something for something. There's price for everything, but we can also do a little bit more job and decide to bring those up, which can be done in next project, or we will do that deliberately, because what I want to show you is how to do a multiplexing of many of the digits to have a possibility of displaying 4 digits, and maybe like a small counter which will be counting up to FF. It will be slow, but we can also try to go for switches here to be changing the speed of counting up to count, not to doing like a one with 1 second. That would take a while. That's it. Thank you very much. See you next time.